Yeah, just lay down on the bed while you're at it. Loser. All right, so we're going over our in-class test, and 67 minus 70 over 8 is equal to 3 negative what? 3 over 8, which is equal to, and if you did it on your calculator, give me 2 digits. What is it? Negative what? I'm sorry, what?
3/8.
Is it 3/8?
Right? You guys want to get 3/8?
Okay. It's just unusual that 3/8 is equal to 0.38. So,
0.37.
what?
It's 0.375.
Okay, 375. I'll take that. Either one of those. Determine the area code. Area codes is non-mathematical. So that means you don't calculate it. So it is a group. So therefore it is qualitative. Now you will see teachers disagree on some groups, but I always like to tell you, if you can't find the midpoint of it, it's like if I give you the ages of 26 to 29. That's a group, but it's quantitative because I can find the what? The midpoint. If you can't find the midpoint of a group, then it's qualitative. Okay? All right. A set of data, convert 138 to a z-score. So that's going to be 138 minus 90 over 12. 138 minus 90 will 10 will give you 100. So 10 will be 48. Somebody check my math.
Yeah, it's 40.
And 48 divided by 12 is 4. This is a what? Normal distribution. Now, what if I had a little blip right there? Then it would be skewed left. What if I had a little blip right there and did not have this blip? It would be skewed what? Skewed right. So this one, the way it looks, the way it is a normal distribution. Does this make sense? We did this in class the other day. Yes, it does make sense. What would not make sense? If it said a standard deviation of 6 feet or a standard deviation of negative 2 feet or negative 2 inches. That wouldn't make sense. Okay? Okay, did y'all survive the in-class test? Okay, so that's that. Let's get that out of the way. And let's move on. Now, we are going into probability now. Probability, and we'll just go over, I'm just going to put up a PowerPoint for today if I can find it. There we go. And clear this. And we'll go down here. What chapter is it? Chapter 4? I think it's chapter 4. Somebody check.
I think it's 7.
Oh, 7. This is 103. I'm sorry. So, chapter 7, and it's going to be 7A. Do we go to 8? I think I can't remember. Look on the outline and see.
It's just 7. We do 4. So it's 7 and then 4.
What do we do? 7 what? What sections?
A, B, C, and E. Yeah, that's the only 7 is in unit 2.
Okay, 7A, B, what?
C and E.
A, B, C, and E, and that's unit 2?
Yeah, that's unit 2.
Okay.
Did you go back to recording?
I think I did. Yeah, I did. Yeah, I'm recording. Make sure. Yeah. Thank you for reminding me. All right, so let me get this thing out of the way. And now, when I get to something, okay, an event. What is an event? An event is something that happens. If I flip a coin, the event is what happens when it falls on heads or tails. That's the event. So if I flip the coin and it falls on tails, the event is tails. Same thing with rolling a die. All right? Now, you're going to find that that's the difference between a mathematical probability and an observed probability. An observed probability is something that you actually do. Okay? Where a mathematical probability is something that is calculated. All right? Consider families of 2 children. List all the possible outcomes for the birth order of boys and girls. If we are only interested in total number of boys in the family, what are the possible events? 2 children. So that would be boy, 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 girl, girl, boy, girl, girl. So the outcomes, there's 4 different outcomes. All right. Now, of course, there's only one possible way to have one of those. In other words, you're not going to have one that's out of that set. It's boy, 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 girl, girl, boy, girl, girl. So you've got 4 outs. The set of outcomes is 4, or events is 4. There they are. Now, you're going to see this again in the homework and the test, because they're going to say, what is the probability of all boys? Well, then you would say 1 out of 4, or 0.25. What is the probability of all girls? 1 out of 4, 0.25. What is the probability of 1 girl? Well, that'd be 2 out of 4, which is 0.5. Because there's 2 there with 1 girl. Okay? Now, I didn't say a girl, did I? I said 1 girl. Because I could have said a girl, and you could have concluded what? The girl, girl on the end. I said 1 girl. Okay? So there again, remember me telling you, probability is all about reading the question, and I just screwed that up. There we go. All right, it's going there. That's what I just told you. Okay? Probability falls within, and write this down. This is a very important slide. Probability falls between 2 numbers. What are those 2 numbers? 0 and 1. Now, that means that probability is measured in decimals. This is where I always tell you about stories about different statistics teachers. The probability of statistics teacher is different. Okay? I'm not a probability of statistics teacher. I'm a math teacher. But when you go to another college later on, when you transfer, you may get a teacher that all they do is teach what? Probability and statistics. They don't teach any other math. They just teach probability and statistics. When I went to Clemson, there was an instructor up there, Dr. Russell. And that man was obsessed with probability and statistics. You ask him an algebra question, I don't care. But you ask him a statistics or a probability question, he'd sit down for an hour and a half and explain it to you. All right? He eat, drink, and slept this stuff. All right? Ate, drunk, and slept this stuff. Whatever you want to say. And if you went in there and said there's a 50% chance, oh, he would go ballistic. Why? Because you don't say percent in probability. It's 0.5 probability. And if you said 50% chance, he'd blow a gasket. All right? Now, the reason I'm telling you that story is to kind of reinforce the decimal. When you're talking about a probability, in my class, you can say 50% or you can say 0.5. I know what you're talking about. But that's the difference between me and Dr. Russell. Dr. Russell would get on you and say, you're not supposed to say 50%. I don't understand what 50% means in this class. That's what he would say. Okay? It's 0.5 probability. So make sure, Xavier, you say 0.5 probability. Don't say 50%. Because you might have some crazy teacher go off on you. Okay? You wait, Xavier. You wait. Okay. All right. So, impossible is close to 0, where certainty is close to 1. Now, this is where I tell my little story. Are we predicting the future? Can people predict the future? And at the words of Medea, hail to the no. People cannot predict the future. Okay? If you ever meet somebody that claims they predict the future, all you have to do is ask them one question. And what is that question? What would you ask them? Y'all are crazy. First thing I would ask them is, what are the 5 numbers for the lottery? What are the 6 numbers for the lottery drawing Wednesday night at midnight? Or 11 o'clock. What are those numbers? And what are they going to say? Oh, well, that's not what I do. You don't tell the future. Period. Okay?
They could see the future pictures.
They would not be telling. They would be in a mansion somewhere, taking up all the money every weekend, winning another lottery. Think about it. What would you do if you could tell the future? If you could legitimately tell the future, would you be on TV going, call Chloe. I miss Chloe. 1-800, I will tell you your future. Or would you just sit at home in your mansion, because you already won 2 or 3 lotteries, and just every other week win another lottery? What would you do? So anybody that tells you they can tell the future, they're full of it. Now, can we take instances and make a prediction? Yes. May not be right. There's a road up here. If you go out this road and turn left, no, that road up there. Turn left and turn right, you go to 24. 24 goes across the lake, and there's a store over here called Garrett's. And there's a red light. And there's a road to the right called Wild Hog Road. Anybody knows where Wild Hog Road goes to? Goes to Pendleton. Straight shot to Pendleton. Right there where the Waffle House is. Comes right out there at that red light. Okay? Wild Hog Road. You're not from around here, it's called 187. Highway 187. Well, hell, Highway 187 is down here going to Sadler's Creek. So that's how you tell if somebody knows what you're talking about. Wild Hog Road. Wild Hog Road is about, I don't know, 10 miles maybe. Okay, and when you get to Pendleton High School is right here. But right down the road from Pendleton High School, it starts to, there's a turning lane right here to go to the left. And there's a red light, and this is Sandy Springs. And of course, this way is Pendleton. Okay, Tri-County Tech's right down the road. Now, it takes you about 16 minutes. When I used to travel from down here close to 187, it used to take me 16 to 20 minutes to get to Pendleton. Okay, there's no red lights. Straight shot. Okay? Unless if you've got to be at Pendleton at 8 o'clock and you turn onto this road, or this road right, when you turn onto this road, if you turn on that road at 7:45, you can forget it. Well, you said 16 to 20 minutes. Nope. Because when you turn on that road, and if you're in a hurry, you're going to get right behind the little blue-haired ladies club. Okay? And that's the little blue-haired ladies club, and they got CPs in their cars. And they communicate with each other. And they're going to go how fast down that road? Well, the speed limit's 45 and 55, depending on where you go. So they're going to go exactly 25 miles an hour. Okay? Are they going to set the cruise on 25? Yes, they are. They are not going above or below 25 miles an hour. They're going to stay right on 25 miles an hour. And here you are, right there on top of them. There you are. Right? Exactly. Well, not on Wild Hog Road. You don't. Okay? So you get down here and you pass Pendleton High School, and you're about 200 yards from this turning lane. And you say to yourself, at this point, you already called your friend in the class, and you've already said, forget it, I'm not going to be there on time. Because right now it's about 8:15. All right, because you've been behind this car going 25 miles an hour. You're coming up to this red light, and what do you usually say to yourself when you get behind a car like this? I bet you $100 they're going to turn left. And as soon as you do, that left turn signal comes on. Now, you've done this before. All right? You've all done it before. The slower the car, the more you get mad, and you sit there and you sit there like this. They get up to the red light, they're going to turn left. I know they are. And just as soon as you say that, it's almost like they got a microphone. Just as soon as you say they're going to turn left, blink, ding, 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 they turn it on, and they're going to turn left. Now, not to mention that people in Anderson, if they were going to go to Sandy Springs, there's another way to go. But if you're going to Clemson or Pendleton, you're going to use Wild Hog Road. So, excluding the fact, mathematically, that if people are taking Wild Hog Road, where are they going? They're going to Pendleton or Clemson. They're not going to Sandy Springs. So chances are they're going to turn left no matter if you're behind them or not. Okay, excluding that information, you've just made a prediction. Based on what? You've made a prediction based on observation, experience, or math. Okay? This one was a combination of observing and math and experience. All right? Why? Because how many of you have gotten behind the little blue-haired ladies club? A lot of you. Okay? A lot of you have gotten behind the little blue-haired ladies club. Okay? And you observed. You got to a certain point and you said, please don't turn right, please don't turn right. And that's when they turn on the blinker. Going to the right. You've done that. And you put those two together and you said that car is going to turn left. And it does. So you've predicted the future. No, you haven't predicted the future. What you just did is you just put the observations and experimentation or experience, you put it to work and say, okay, this is what's going to happen. Mathematically, logically, you could say to yourself that if a person is coming from Anderson and they're using Wild Hog Road, they're not going to Sandy Springs because Sandy Springs is closer to what? To Anderson. So they're not going to Anderson. They're going to Pendleton or Clemson or Central because there's no way to get to Pendleton unless you just go Clemson Boulevard, which is the way to Sandy Springs. So Clemson Boulevard is right here. So if you're not going Clemson Boulevard, chances are you live over in this area and you're going to Pendleton or blah, blah, blah. So that's the mathematical or the logic behind it. But you made a prediction. What we do in probability is we use these things to place a number on a prediction. Okay, that's what probability does. We place a number on a prediction. That number is between 0 and 1. 0.98, would be very, very likely. There's a 0.98 probability this car is going to turn left when we get to that red light. That's a very strong prediction. There's a 0.01 chance that that person's going to turn right when we get to the red light, and they turn left. Okay? So that's what probability does. Now, there's two types of probability. There is the probability that you calculate. What is the percent? Let me ask you this. What is the probability of that car turning left or right at the red light? Now, wait a minute. Let me. Okay. Wild Hog Road dead ends into Clemson Boulevard. I have to put that in again. Okay. So what's the probability of the little blue-haired lady turning left or right? Huh? What'd you say? Okay, I thought he said something. Okay, that's not rhetorical. I'm asking y'all. Huh? What's that decimal?
Oh, like 0.75.
0.5. Because there's left, or what? Right. There's only two ways to go. True or false. 0 or 1. Black or white. All right? You only got two possibilities. Left or what? Right. So mathematically, there's a 0.5 probability that they're going to turn left or right, whichever, because that's how many sides there are to a coin. That's how many sides there are to a dead end. Left and right. So mathematically, there's a 0.5 probability that they're going to turn left. That's called classic probability. It's called classic probability, where you calculate with no observation. What is the probability of picking a face card out of a deck of cards? That's not rhetorical, I'm asking y'all. How many face cards are there? 3. 3 in each suit, 12 in a deck of cards, Hubert. That's right, class. So 12 out of 52. I just used mathematical calculations to do that based on, I don't even have a deck of cards in front of me. I just used what is in a deck of cards, and you calculated in my head. So there's a 12 out of 52 chance, which is equal to, I don't know, 10 out of 5, 2 to 0.2. There's a 0.16 or 0.2 probability that I'm going to pick a face card out of a deck of cards. Okay? That's mathematical probability. I don't even have a deck of cards in front of me. Okay? Versus the observation probability, where you actually take a deck of cards, and we'll do this when y'all come back. What day is today? Wednesday? So Monday, we'll take a deck of cards and did I do that with y'all in the 120 class? A deck of cards and a die, and we'll actually see the difference between classic probability and physical probability. Okay? Now, what about this person? Well, the person behind the little blue-haired ladies club, let's say they've gotten behind the person on Wild Hog Road 15 times. And 14 out of the 15 times, that person turned left when they got up to, well, then you're using physical probability. You're using something that you've observed versus something that you just remember in your head. That's the difference between the two types of probabilities. You could figure the probability of having a boy and a girl all day long. But after you've been pregnant 3 times, then that's a little bit different from predicting if you've never been pregnant before. Okay? That's 2 different probabilities. 2 different ways to calculate. For instance, if I take I think I've just lost it. There we go. If I say the probability of picking a king is equal to 4 out of 52, which is equal to 1 over 13, that's a very slim probability. So I know that if I get a deck of cards and I shuffle it 3 or 4 times, I know that my probability of picking a king is going to be close to what? 0. Okay. Now, if let's say that I've got this deck of cards in my hand right now, and I pick one, and it's a 2. And I shuffle, I pick one, and it's a queen. And then I shuffle, and I pick one, and it's an ace. And then I shuffle, and I pick one, and it's a 3. And then I shuffle, and I pick one, and it's a king. Then my probability is 1 out of what? 5, which is 0.2. Somebody calculate 1 out of 13, what do you get?
0.07.
0.07. Why don't they match? They won't match. Because 1 is mathematical and 1 is observation. Okay? And that's the difference between the two types of probabilities. To make a note about that, because we're going to go over that Monday. We're going to play with the cards. We're going to play poker. That'll get everybody, that'll get all the administrators psyched up. Oh, Hubert's playing poker in his classes. Listen, all I need to do is do one little thing, and I guarantee you it'd be at the Pendleton campus before you could even get up there.
You have a work email.
All right. What is probability? Write that down. It's the number of events that happen over the number of events that can occur. Big numbers always on the bottom. For instance, if I flip a coin, how many sides of a coin are there?
2.
So 2 is going to go on the bottom. If it comes up to be heads, then the probability of heads is 1 over 2. Well, there's only one side that it can fall on. So the probability of left and right at a dead end is 50-50. 0.5 and 0.5. The probability of a head on a flipped coin is 0.5. The probability of a tail is 0.5 because there's 2 sides. Probability of a king. Well, king is what you're wanting. Out of how many cards? 52. Be 4 out of 52. I've never heard that sound on my phone. That's what I was wondering what it was. Okay. Oops. Apply the theoretical method to find the probability of exactly one head when you toss 2 coins. Well, what is the probability of a head on a coin? It's 0.5. So that'd be 0.5 on one and 0.5 on the other. Okay? Getting a 3 when you roll a 6-sided die. Well, how many 3s are on a die? 1. So that'd be 1 over 6. Those are calculated. They're mathematical probabilities. I don't have a coin in my hand and I don't have a die in my hand, but I'm figuring the probability. Okay, 1/2, 1/6. So these are calculated mathematical probabilities, and they call it the theoretical method. There are 52 playing cards in the standard deck. There are 4 suits known as hearts, spades, diamonds, and clubs. I always call them puppy feet. Clubs. What the heck are they supposed to be anyway? I know, they look more like a club is something you beat somebody over the head with. They look like little blackberries or a flower or a clover. They don't look like a club. I don't know. It's Russian's fault. Each suit has cards for the numbers 2 through 10, plus a jack, king, queen, and ace, for a total of 13 cards in each suit. Notice that hearts and diamonds are red, while spades and clubs are black. If you draw one card at random from a deck, what is the probability that it is a spade? Well, there's 26 black cards in the deck, because the other 26 are red. So what is 26 over 52? 0.5. 0.5 probability. Again, I don't even have a deck of cards in my hand, but I've just done probability. That's the difference. That's wrong. Oh, spade. I'm sorry. I thought it was black. I'm sorry. What's the probability of a spade? 13 out of 52, which is 1/4. I'm sorry. There's your boy, girls again. Assuming an equal chance of having a boy or girl at birth, what is the probability of having 2 girls and 2 boys in a family of 4 children? So now you got to do all those. These are what drives you crazy, trying to figure these things. My suggestion to you when you're dealing with these is I would go ahead and pull, you know how to do 2 boys, 2 children. 3 children is not that bad. But when you get 4, 5, and 6, go to Google, print it out, and put it on a card. I'm serious. You'll spend 30 minutes trying to figure this out right here. I mean, honestly. Okay, girl, 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 boy, girl, girl, boy, girl, girl, boy, girl, girl, boy, girl, girl, girl. Go drive yourself crazy. So what is of having 2 girls and 2 boys? Well, that's this one right here. How many out of the whole group? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 6 out of what? 16, which comes out to be whatever probability. 0.357. Again, nobody's pregnant, nobody's had any children. This is mathematical. Now, relative frequency method, the empirical, we talked about this. We've done this. 2 heads occurs 27. This is the same thing. But this is when you actually flip the coin. All right? This is observing. Now, you'll notice that out of so many times, you're talking about flipping. We're going to move into the big number rule in just a few minutes, probably. And that's based on what this is. Okay? I'm not going to go into that right now. Okay, I want you to look at this. This is the relative frequencies. All right, let me back up because you need to know the difference between the two. I'm sorry. All right, look at these 3. 0 heads in 22 times, 1 head in 51 times, 2 heads in 27 times. So those probabilities are going to be 0 out of 22, 1 out of 51, and 2 out of 27. Okay? And that's what they're going to be doing right here. 0. And those are the ones that they're figuring based on the 0 heads is going to be 0.25%. 1 head is going to be, and they're figuring up the head, tails, head, tails. So there's 4 in the group. All right, 2 coins, and that's where they're figuring that. The relative frequencies, there's where they're figuring the 22, 51, and 27 out of 100, which is changing it basically to a fraction, a percent or a decimal. It's not really important, but right now I'm just trying to teach you the probability. Here we go. Okay, this is theoretical based on the assumption that all outcomes are equally likely to determine. Write this down. theoretical probability is very important, is based on just the mathematics. And put 4 kings out of 52 and rolling a 6 on a die. Those are 2 theoretical probabilities. I have no die, I have no cards, but I can tell you what the probability is of a king. Relative frequency is based on observations. That's where we're going to do Monday. We're going to do the relative frequency probability. We're going to roll a die 20 times, and we're going to shuffle the cards 20 times and draw and see what we come out with. And subjective probability is an estimate based on experience or intuition. The little old lady on Wild Hog Road is subjective probability. Now, it's pessimistic when you say, well, I'm having a terrible day today, my car sucks, I wasn't able to take a shower before I left, and this old battle axe, she's probably going to turn left. That's not subjective, okay? That is a little bit on the pessimistic side, okay? So I wouldn't go with that. I suck, I'm a loser, I shouldn't even go to school, I should quit. Things might have been a whole lot different if you started earlier. You wouldn't be so pessimistic. Identify the methods that resulted in the following statement. I am 100% certain that you'll be happy with this car. I would say that's a little bit what? Subjective. You don't have anything to what? Huh? You don't have anything experienced and nothing mathematical. That's just a salesman trying to what? Sell you a car. So that is subjective. Look up the word subjective. What does subjective mean? It's my Google. That's all right. Well, I would. I'll Google it. What does it mean?
Based on the influence of personal feelings.
Personal what? That's what I was wanting. Personal feelings. Okay? That's subjective. Based on government data. The chance of dying in an automobile accident during a 1-year period is about 1 in 8,000. All right? It's not subjective because you got data. Whenever you got data, are you sitting out there and watching the cars for a wreck? No. You have data. So this is what? Sounds sophisticated when you say it. Theoretical. It's theoretical, executive. Can you say theoretical? Okay. Impress people. Relative. Okay? I don't think that's right. No. That's theoretical. Theoretical is based on mathematics. But you will get statistics teachers. You will get mathematical teachers. Okay, here's another thing. The probability of rolling a 7 with a 12-sided die is 1/12. That's again based on mathematics. That's theoretical. Okay? I'm not going to say that last one wasn't relative, because you do not observe it. That is data. That is data that's been given to you. Now, if you compiled that data, then would it be relative or would it be relative or theoretical? It's theoretical when you haven't compiled the data, but if you have compiled the data, then it's what? It's relative. You see what I'm saying? You can't just say, "Oh, well, that's done. What time is it? Oh, that's all this data right here. I didn't do it, so it's relative." No, it's theoretical because you didn't do it. It's based on somebody else's stuff. Okay? So I disagree with that one. Okay? We're going to shut it off right there. because I don't want to go over, because they're going to break down the door, they always do. So, we're going to finish it up, we're going to finish this section, we'll finish it, y'all need to finish up your homework and do all that stuff. When's homework due?